The first phenomena we will discuss is wave interference, both constructive and deconstructive. Constructive interference occurs when there is a disturbance on each end of the medium, but on the same side of the equilibrium position. The two waves are added together and form the resultant wave. Here, we will show constructive interference in slow motion to better show the waves. Libby and Katie send two waves down the rope, wave A and wave B. Notice the crests of the waves are on the same side of the equilibrium position. They meet and combine for a short amount of time, creating the resultant wave, C. The waves then pass through each other and regain their shape. Wave A continues away from Libby and wave B continues away from Katie. Destructive interference occurs when there is a disturbance on each end of the medium on opposite sides of the equilibrium position. Thus, one wave is positive and the other is negative. The combination of the two waves is the resultant wave. If the waves are the same size and on opposite sides of the equilibrium position, complete destructive interference occurs and the two waves cancel each other out. Again, Katie and Libby send two waves down the rope, wave A and wave B. Notice the crests are on opposite sides of the equilibrium position. The waves meet and form the resultant wave, C. Because wave A and B were not the same size, they did not cancel each other out for complete destructive interference. But because wave B was on opposite sides of the equilibrium position from wave A, it reduced the size of wave A. Once they pass through each other, wave A continues away from Libby and wave B continues away from Katie. The other phenomena we're going to talk about is dispersion, which means we get to learn about rainbows. Hooray! Dispersion in the case of rainbows essentially means the separation of white light into its constituent colors, red, orange, yellow, green, blue, indigo, and violet, also known as Roy G. Biv, the colors of the rainbow. In order to create rainbows, we used a white flashlight and a piece of crystal. As the white light from the flashlight passes through the crystal, rainbows appear. This occurs because the crystal acts as a prism, taking white light and dispersing it into the constituent colors. Red is traditionally the outer part of a rainbow, and violet is traditionally the inner part of a rainbow, due to the amount they bend or refract in prisms. Look for these phenomena in your life. Look for the rainbows after it rains, or the rainbows in your mirror in the morning. Think about the waves in a pool when they react. Think about the dead or loud spots you come across when you're listening to music on speakers. Remember when you used to play with a slinky and it would make all those cool waves? Or how about noise-canceling headphones? They apply it to technology. Think about it.